So far, we've learned how to find inverses on a graph, but now how do we do it with an equation? So the inverse is a reflection across the y equal to x line. And this is the exact same thing as flipping x and y. That's effectively what you're doing there. So if a function is 1-to-1, then all you have to do is flip x and y, and then you can solve for y, and that will give you the inverse function. If it's not 1-to-1, then you can't do this. So first off, I'm going to change f of x to y, and then I'm going to flip x and y. So flip them. X equals y plus 2 cubed. Now all I have to do is solve for y. So the first step I'm going to do is I'm going to take the square root of both sides, or sorry, the cube root of both sides. So we're going to get the cube root of x equals y plus 2. Then all I have to do is subtract 2. And that is my inverse function. Likewise, I'm going to flip x and y. Okay, add 14. Now divide by 3. So my inverse function is x plus 14 over 3. Now, if you compose them both ways, if you actually do this one plugged into this one, compose them both ways, you're going to get x as a result. And you have to make sure that you compose it both ways. So you could say this is g of x, right? Do f of g of x and g of f of x. Same thing true with this one. Give them this is g of x, this is f of x, whatever you want to do. Compose them both ways. But I also want to show you that on the graph. So here we had x plus 2 cubed, and we got as a result the cube root of x plus 2. Okay, here we have x plus 2 cubed, and then the cube root of x minus 2. And I should draw the y equal x line here, make it black. And you can see it is in fact a reflection over this line. So I did find the correct inverse function. Now for the next one, we had y equals 3x minus 14. And we found x plus 14 over 3 as the inverse. So here are the two lines, and you can see they are reflecting images across the y equal x line. Okay, now using function notation, we like to write inverses as whatever the function name is, in this case f of x. Then you would write it as f inverse of x. This is not the reciprocal function. So normally when you see x to the minus 1, you'd think 1 over x. That's the case for when you're working with variables. But f is not a variable. F is a name of a function. So here, f inverse of x means the inverse function. If I hadn't said f of x like this, that would be the reciprocal, 1 over f of x. So it's important to note what the how it's written here. It's going to be very easy to be confused if you don't understand how to read the notation. Okay, so f of x equals this rational function. What's f inverse of x? Well, I'm going to first change f of x to y and do the same process. I'm going to flip x and y. Now there's two x's here. That's fine. Change them both to y and change the y to x. Okay, now we're going to solve for y. to do this, I'm going to need to multiply by y plus 1 to both sides. That'll give me y plus 1 times x equals 2y minus 3. I can distribute the x. And now I can get the the y's together. And in the meantime, I'm going to get the x's the other side as well. At this point, I can factor out the y. And that's going to give me y x minus 2 equals negative 3 minus x. I can just divide by x minus 2 now. That'll give me my final simplified form here. And drop these parentheses. Okay, so I'm going to rewrite this not as y now, but as f inverse of x. And of course, if you compose them both ways, f of f inverse of x, you'll see you're going to get x. And if you do the other way, you'll also get x both ways. I'm actually going to graph this here. So this was our original function f of x. Let's graph f inverse of x. Okay, Desmos didn't like the inverse notation, so I'm just going to leave it like this. I'm also going to graph the line y equals x. And this is what I get. So you can see that this is a mirror image across this y equal to x line. This red portion flipped up to be this blue portion here. This red portion flipped down to be this blue portion down here. So it is the reciprocal of it. Give it a try in number 5. Now, inverses are used frequently, and if they're used frequently enough, they're given their own notation. Addition and subtraction, they are inverse functions, as well as multiplication and division. And as we've seen, there are some radicals that are inverses of powers. So the square root and square doesn't quite, they're not quite inverses of each other. But any odd power and any odd radical, the power on there being odd, those will be inverses. They satisfy the definition of the inverse. Now, what about a function like this? 3 to the power of x. This is not the same thing as this one. This is a monomial polynomial function, right? X cubed. Here we have 3 to the power of x. Now, you cannot, take the xth root of this. That doesn't make sense because that's a function itself. What we need to do is we actually need to move this base 3, because it's base to a power of x. We need to move this base 3 to the other side of the function. And we do this by creating a new function called the logarithm. And this is the inverse of this function here. We have 3 to the power of x. The inverse is log base 3. Now, each base changes, each base of the exponent changes the base of the logarithm. So you're actually going to get different functions. So for instance, 10 to the power of x is different than 3 to the x, as is log base 10 to the power, log base 10 of x and log base 3 of x. I just wanted to show you what the graphs look like. Here we have x cubed and the cube root of x, that flips like this. You get the x cubed graph, and then of course it reflects across like this. And this is 3 to the power of x. And this is log base 3 to the x. I just want to make sure you understand the difference between x to the power of 3 and 3 to the power of x. They're different functions with different inverses.